Welcome to Circuits and Devices Lab. In today's video, we are going to learn how the experiment number 7 FWR, that is full wave rectifier, can be performed using Virtual Lab. So for that, you have to go to the Google and type Virtual Lab in the search bar. Then you have to click the electronics and communication branch as I have shown in the previous video. Follow the same procedure and then click the basic electronics lab. So select this lab. Once you select, it will be shown the introduction of virtual lab. In that you have to select the list of experiments. So under the list of experiments developed in this branch, we have to do the full wave rectifier. So for that, click the 7th experiment, full wave rectification. So select that. So once you select that, the first page shows the theory part of full wave rectifier. So in full wave rectifier, rectifier means it is a device that converts alternating current to direct current, AC signal to DC signal. So this process is known as rectification. Rectifiers are of two types, half wave rectifier and full wave rectifier. In today's experiment, we are going to do the full wave rectifier. A full wave rectifier converts the whole of the input waveform into one of constant polarity, either positive or negative, at its output. So now this page covers the theory part of full wave rectifier. So read it once and then go to the next tab on the top, which is procedure. So this gives the step-by-step procedure to do the full wave rectifier. So we are going to use a bridge rectifier, and this covers the instructions to be followed to perform this experiment. So bridge rectifier produces desired output but does not require a special center tapped transformer, thereby reducing its size and cost. So we are using bridge rectifier to perform this full wave rectification. So now we move on to the simulation tab to start our experiment. So go to the simulation tab. So here we are going to perform our experiment, which is full wave rectifier, by clicking this first tab. So this shows your circuit diagram of full wave rectifier with a bridge circuit. So it consists of an oscilloscope. So this oscilloscope displays a voltage waveform versus time. So it has a screen to display the waveform. So oscilloscope has screen. So the screen is shown here. So this is your screen of oscilloscope, and then it also consists of input jacks for connecting the signal to be displayed, and it also has the control tab how the signal will be displayed. Now we move on to the procedure. So you can also go for instruction and read this instruction to perform the full wave rectifier experiment. So first step, say in bridge rectifier, full wave rectifier is done in bridge circuit. So first step is set the resistor RL to some value. So this is your load resistance. You have to set the value to some resistance of 1000 ohm, which is 1 kilo ohm. And second step, you have to click the on button. So this is your on button. So you have to click the on button to start the experiment. So I have pressed the on button, and now the screen is displayed in the oscilloscope. The second step, click on sine wave. So this is your input signal, sine wave. So click on sine wave button to generate the input waveform. Next step, you have to vary the amplitude. So this is your amplitude knob, and then this is your frequency knob. So you can vary this frequency knob by clicking this circle. So you can vary this frequency, and you can also vary the amplitude value of the input signal. So this is your input signal which is displayed in the oscilloscope, which is CRO, cathode ray oscilloscope. So this is your input signal. So you can vary the amplitude. See, the amplitude means height of the signal is varied according to our wish. You can set any value. So for example, I have set the amplitude to 1.3 volt, and this is your amplitude value which change the y-axis, and the frequency means 3000 Hz. I have set the value to 3500 now. You can set any value according to your wish. So by adjusting frequency and amplitude value, the input signal can be set to any value. So next step, click on oscilloscope button. So this is your oscilloscope button. So you have to click this oscilloscope button to get the rectified output. So when you click the sine button, your input signal is displayed in the oscilloscope, and if you click the oscilloscope button, it will be shown output, that is rectified output in the oscilloscope. So this is your output. So this output which shows the conversion of AC signal to DC signal. So in order to see both the input and output signal in one display, just you can click the dual button of this window. So you can just click the dual button. So this shows both the input. So this is blue color shows the input signal, and red color shows the output signal. So you can split these two signals by varying the control in the Y position. So channel 1, if you vary the channel 1, so I am just adjusting the channel 1 so that my input signal is varied to some value. And then you can vary the output signal. You can change the position of output signal, Y position, by varying this control slider. So just you can see the output. So if you click the dual button, both the input and output are shown in one display. So blue color is the input signal and red color is the output signal. Now you can see the input signal is the alternating current. So this is positive and this is negative of the signal. So both positive and negatives are shown in the input signal, which is alternating current. But in the output signal, the negative part of this input signal is given in the positive side, which means alternating current is converted to the direct current. The negative signal is placed in the positive cycle. So this negative side is placed in the positive side. So all the signals are in one polarity, that is positive polarities. So thus you can see the alternating current is converted to direct current by the use of full wave rectifier. So you can also do the calculations by the use of this formula. The peak current value is 0.59 milliampere. So thanks for watching.